the breaking news. The instrument we've been working for 15 years is finally ready, and we could start observation of the universe using this new instrument. This instrument is called Prime Focus Spectrograph, PFS for short, and that is sitting on the Subaru telescope atop the Mauna Kea on the big island of Hawaii. Subaru is a very big telescope that has a mirror which is as big as 8.2 meters. So with this giant mirror, we can collect a lot of light coming from faraway galaxies and also nearby faint stars. What we would like to do with this instrument is, first of all, the light comes from faraway object, bounces back by this big mirror, and that goes into the instrument that is sitting 60 meters above there. And there are so many different objects that would send light to our telescope that they get bounced back, and we need to control the optical fiber cables within 10 micron kind of accuracy to really capture the light coming from this specific star or specific galaxy. Once you capture the light, the optical fiber cables would route them to the nearby room, and then each light gets separated to something like 4,000 colors. So we get a lot of information about what the star is made of, how the galaxy is moving, and so on and so forth. And so using this telescope, we can actually capture a lot of information. And because we can observe 2,400 objects at the same time, kind of observation that might have taken thousands of years can now be done in just a few years. So that is the program we've been dreaming about for 15 years, and now it has finally started observation. Using this instrument, what we can do is to try to think about where the universe is going today. So right now, what we know is that there's something called dark energy that is ripping the universe apart. Does it keep getting ripped apart and the universe would end? Or maybe it will actually start to slow down again and the universe would go on forever. We just don't know. So using this instrument, we try to understand where the universe is going. So that is an area called cosmology. Another area we'd like to do is something called galactic archaeology that will tell us how a Milky Way galaxy has been assembled and what a nearby little village called dwarf galaxies had been working for a long time. Especially that looking at the motion of stars, we can tell how dark matter has built up a galaxy and what they're doing right now. Are they hitting each other? Are they going through each other? So that kind of thing about the nature of dark matter is something we like to understand too. Finally, there's an area called galactic evolution. So what's going on here is that our galaxy is now aging. It's not producing that many stars anymore. So it's actually getting dimmer and dimmer at the end of the day. But there was a period of the baby boom in the universe if you actually look at the very far away galaxies. And if we further go back in time, there was a time when the galaxy was just beginning to born, stars were being born, so that is the dawn of the universe. So why universe came up from this dawn to high noon, the baby boomers, and eventually to the aging galaxies is something we don't understand either. So we would like to also trying to understand this evolution of galaxies in the history of the universe. So as I said already, this observation has just gotten started, and we think that will go on for 5 or 6 years. So there will be a lot of science coming out of the instrument. So please watch to see what kind of science will come from this instrument. Thank you.